Okay, why should we study the brain? First, most obvious reason, know thyself. Know what this thing is that's operating in our heads. This is who you are, right? Is your brain. There are lots of very fine and important organs in the body, but the brain is special, right? So, a heart is important. You'd die without it. But it's the brain that's your identity, right? So there's a reason that surgeons do heart transplants. That makes sense. Something wrong with your heart, you need another heart, okay? But why don't they do brain transplants? That wouldn't make sense, right? If there's something wrong with my brain, it doesn't make sense to take someone else's brain and put it in here, because then I'd be that other person. It doesn't make sense, because the brain is who you are. Okay, so the brain is really special. It's not just another organ. That's why a few years ago we had the decade of the brain, right? Not the decade of the pancreas or the liver or the kidney, right? People need to study these things. They know how to fix them. They need to know how to fix them. They're important, but they're not as cosmic as the brain. Okay. All right. Second reason why we should understand brains, and that is to understand the limits of human knowledge. Like, the more we understand about the human mind, the more we can actually evaluate how good our knowledge is. Are there things that we might not be able to think? Possible true scientific theories we might not be able to understand ever? You can think of studying the mind as a kind of empirical epistemology, a way to actually know about the knower so we can figure out how good the knowledge is in that knower. Right? So that's another reason. A third reason is to advance AI. And so up until a few years ago, I used to give lectures on vision, and they would all start with some version of this. You guys all have amazing visual abilities in the back third of your brain that does vision. You can do all this incredible stuff that no machine can touch. Hats off to you. You have an amazing visual system back here, and those guys in AI, it is mostly guys, gals, whatever, those people in AI, could only dream of coming up with algorithms as good as the one that's running in the back of your head. You can't quite start the lectures that way anymore. So if any of you have been living in a cave and not heard about deep nets, there's been a massive revolution. And all of a sudden, deep nets are doing things that are really close to human abilities, particularly in vision. So for example, in visual object recognition, machines were way far behind human vision until very recently, especially when this paper here came out, was published in 2012, first author Krzyzewski. It has now been cited an astonishing 33,000 times. Actually, I made this slide a couple weeks ago. It's probably been cited 36,000 times by now. You could look it up on Google Scholar and find out. That is a huge number of citations. The influence of this paper is ginormous. Probably half of you have already heard about this paper. Raise your hand if you've heard about this paper. Oh, okay, all right. Right, major big news. Okay, so what's so important about this paper? Well, they trained, as probably most of you know, they trained a deep net on the over 1 million images in ImageNet, a massive computer database of images, and they basically taught it to do object recognition. And it performs much more accurately than any previous system, and it approaches human abilities. Okay, so this is major. This is a radical change in the situation that we were in 5 years ago. So things have changed radically. So pretty amazing, and nothing even close to this was possible before 2012. So this is very recent history, and it has totally shaken up the field in lots of ways. And so that's been transformative, not just for computer science, but it's also been transformative for cognitive science and neuroscience. Because now we have algorithms, like here's this deep net and it does this thing. So that's a possible theory of how humans do it. It's a possible computationally precise theory of what's going on in here. And we didn't used to have those, and now we have those for a number of domains, and that's shaking up the field.